Okay, good morning, class. Today we would like to talk about things that students need to know for getting to calculus. So all the essential content that you learn from pre-cal, all the concept, so all the necessary stuff that you need to know. So especially for concept-wise like functions, graph, formulas. So we'll talk about those type of the structures. Okay, so let's start it off with linear function. So back to algebra 1, something they learned from linear functions, so that will be considered y equals mx plus b. So slope-intercept form. So the way that we apply for the slope-intercept form in calculus, so we're using that as f of x. So that would be considered f prime of x, and then times the difference of x minus a, and then plus f of a. So you might be wondering what kind of structure that is. So that's something you'll be dealing with in calculus. So what I'm doing here is just like a comparison. So things that you learn from algebra 1 and then versus calculus. And then the other one, it's the point slope form, which is y minus y1 equals the slope times the difference of x minus x1. And then compare back to this form, so this one is quite similar. Well, obviously the slope formula. The slope formula then that we consider y2 minus y1 over x2 minus x1. And in calculus, this one would be considered derivative of prime of x. Okay? So we'll find out the meaning of those two in calculus. And then for number 4, so we do have a quadratic equation. So quadratic equation normally is written as ax squared plus bx plus c. And also this one can be written as the vertex form, which is a times x minus h quantity squared plus k. So the first one, this one is called the standard form. And the other one is the vertex. Well, there's another form for the quadratic, which is considered x-intercept. So it's y equals a times the quantity of x minus p, and then times x minus q. So by the time that you sketch the graph for this quadratic functions, we can find the vertex and the y-intercept. And then for the vertex form, h and k, obviously that's the vertex. So in calculus, it's called either the maximum or the minimum. And then a, it just tells you the rate of change. Okay? And then for y equals a times x minus p, x minus q, so that would give you the zeros. So that will show you the x-intercept. And now let's see what else that we have for the rest of the functions that you learned from pre-cal. And then for number 5, we do have the absolute value. So y equals a times x minus h plus k. Okay, so absolute value graph is always considered, it's a V shape. Okay. And then for the linear, so it's kind of like a linear function, but that's a V shape. One is going to the negative direction, the other one is going to the positive direction. So, and then for the line graph, we do have a linear function. And quadratic, it's always considered a parabola. Again, the one that I'm drawing here, those are just the parent graph of the linear functions, quadratic, and then the absolute value. And now let's see what else that we have for the rest of this. So the next one, we're going to have a rational function. So y equals a over x minus h plus k. So for a rational function, so the one that we're dealing with is the vertical asymptote and the horizontal asymptote. So normally for the graph, if that's not showing h and k, so that means that would be the x-axis, the y-axis. So the value of h, then that would be considered the VA, vertical asymptote. And then k, then that would be considered the horizontal asymptote. Okay, so one is going this way, the other one is going that way. Again, it's all about the parent graph. And then for number 7, we have a polynomial. Polynomial is always written with the high power, so it's a x to the power of n plus b x to the power of n minus 1, and then plus c x to the power of n minus 2, and then so on and so forth. As you can see, the power here is decreasing. And then eventually it's going to reach to the constant. So let's say the constant it's any letter, any arbitrary letter. So let's say that's z. Okay, so that keeps going. So polynomial functions. So the graph normally is like a random curve, like uphill, downhill. It's like a continuation. Okay. And now let's see what else that we have. We do have linear, quadratic, absolute value, rational. Okay. Polynomial. And the next one we'll be doing, that we consider radical. So radical, that means it's considered either square root, cube root, 4 root, 5th root, so on and so forth. So let's talk about the odd root. So let's say we do have a radical function. And that's number 8. So let's say that n is considered odd number. So for example, we do have cube root, 5th root, 7th root, and so on and so forth. Again, with the variable x. So anytime that I deal with the odd root, so that means the parent graph, it's like a sideways cubic curve. The nickname for that, I'll call it a snake. Okay, so it looks like a snake. So anytime that I deal with the odd root number, with the radical, it's always going this way. So either the width of this is getting narrow or it's getting wider. Okay, so it's all depends. And then let's say n is considered even. So let's say we do have an even radical, even root. So for example, we do have square root, 4 root, 6 root. So that means the graph, it's always considered the half sideways parabola. Okay. So for the radical functions, so we do have 2 different scenarios, the odd root and then the even. And now, what else do the student need to know for calculus? Before they started with calculus, things that you learned from pre-calc. So the one we talked about, that was radical. And then the next one would be considered exponential and logarithm functions. Well, let's talk about the exponential function first. So we do have 2 different types of exponential functions. So exponential function, we do have y equals a b to the power of x minus h plus k. So where a is just a scale factor, so it tells you whether the graph is considered stretching, shrinking, and then b is the base, and then h. So h for this one is just the horizontal shift. Again, anytime they deal with that a, h, and k, so they always have the same kind of meaning. And then k, which is the vertical shift. Now, but there's another implication here. So let's say that you're dealing with exponential functions, the value of k. It's not just being the vertical shift, but also it's considered a horizontal asymptote. So anytime that I deal with the exponential function, y equals k, it's always the horizontal asymptote. So for the parent graph, it looks like this. Exponential growth. So if you see the graph like this, that means the x-axis would be considered the horizontal asymptote. Or it could be considered exponential decay. So it's going the other way around. Or you can say that's being reflected. Okay. Or it could be going this way. Exponential growth. Exponential decay. So the one that I'm showing you is just like a different scenarios for the exponential growth and decay. So now the next one, then that'll be considered logarithm, the logarithmic function. Again, we're going to use that the transformational element a, h, and k. So for number 10, so the log function. So we do have 2 different types of log. One is just log, and the other one is natural log. So for the regular log, so it's y equals a times log of base b, and then quantity of x minus h plus k. Again, the reason why I'm not putting any number here, this one is just like a general structure, the way to recognize the transformational constant. Okay, so the value of a, again, the scale factor, and then h, which is the horizontal shift, and then k, the vertical shift. And then h, there's another b name for h right here. So back to the exponential function, y equals k, then that's the horizontal asymptote. And guess what h stands for right here? So this one is considered a vertical asymptote. So that means the graph eventually is going to be bounded like this. So let's say the y-axis would be the vertical asymptote. So that means it shows the boundary of the logarithmic functions. And for the natural log, it's similar. So a times natural log of x minus h plus k. And for those who might be wondering what's the difference of log and natural log. So for the regular log, the base, we can use any constant. Can be positive, can be negative for the base. But for the natural log, the base is always considered e. The value of e, which is considered exponential constant. So I try to approximate it, it's about 2.7, blah, blah, blah. So this one is non-stop. So just like the value of pi, 3.1415256, keeps going on, irrational constant. Okay? So now let's see what we got. So we do have 10 different type of functions so far. And then the rest of this, guess what? It's going to be considered a trig function. So normally we do have 6 different type of trig functions. So we can always generate that with the transformational form as well. So we can talk about like transformations such as the amplitude, the scale factor, the way to find a period, the phase shift, and also the vertical translation. Okay, so now let's talk about the trig function. So for the trig function, we do have cosine, sine, tangent, cotangent, secant, and cosecant. So let's start it off with cosine. So let's say that the basic form for cosine is always written as A, capital A. That means it's an amplitude. The height of the function. So cosine of, well, let's say A cosine of bx. And then the value of b is just a scale factor. It's a scale factor, so we're using that to find the period. So normally the way to find a period is considered 2 pi divided by b. If b is not shown, that means it's always 1. And the graph for cosine, it's always considered a bell curve. It's upside down bell curve. So starting at 0, and then it ends all the way at 2 pi. And then amplitude here, we do have 1. Down here, we do have negative 1. And the midpoint right between 0 and 2 pi, which is pi. So the more complicated structure for the transformation, so this one is written as y equals a cosine of b times the quantity of x minus h plus k. Again, a and b, it all stands with the exact same element, amplitude, scale factor, and then h and k. H, which is considered a horizontal phase shift, and then k. Okay, so this one is just the phase shift. And then k, it's just the vertical translation. So basically that means the exact same thing as what we talked about for the algebraic function. And normally, another thing that you want to find out is cycle. So for those you might be wondering, how do I start with the graph? Which point do I start with? Initial or the final position of the graph for the one cycle? So the one cycle test that we're using for this, so that would be considered 0 all the way to 2 pi. Well, because that back to the parent graph, so it shows that from 0 to 2 pi. So anytime they see the element right after that cosine, so we want to put it in here to find out the boundary of the variable. So this one, it just tells you the initial position. And then this part right here, it shows the final position. And the good thing about doing this, so anytime that you do the one cycle test, it's not just finding about the initial final, but also takes care of the period, and also it will take care of the phase shift. So once you do this, so that takes care of 3 things. The initial position, the final position, the period, and then the phase shift. And now for the next one, then that'd be what? Sine. So quite similar. Again, it's the similar structure. Instead of using cosine, we're just using sine. And for the parent graph of sine, it's considered a roller coaster. Again, as you can see, the period, it's from 0 to 2 pi. And then the amplitude, it's from -1 all the way to 1. Again, for the transformational form, the one cycle test, we use the exact same boundary from 0 to 2 pi. Again, whatever that you solve for x right here, the boundary, so it shows you the initial position and the final position. Now, for those you might be wondering, what about for tangent and cotangent? So we'll talk about those later. So the next one I would like to talk about here would be considered secant and cosecant. The reason why that I want to talk about secant and cosecant, because secant is based off the graph of cosine, the reciprocal, and then cosecant is based on the graph of sine. So imagine that this one is just a reference graph for secant. So for those who might be wondering about the form, again, instead of using cosine, we're using secant. Secant. Now, if that's a reciprocal, so what's the reciprocals of 1? So that's considered 1. What about the reciprocals of 0? Then that would be considered 1 over 0, which is considered undefined. Well, if the position is being undefined, that means it's considered a vertical asymptote. Again, reciprocals of -1, then that would be -1. And reciprocal of 0, again, it's being undefined. So anytime they see the undefined position, you'll see the vertical asymptote. Now, what happened at the max and the minimum position here? So anytime they see the max and the min, those are the vertices for the parabola. The vertices for the parabola of the secant graph. So eventually, this one's going to be bounded like this. Down here, it's going to be bounded upside down parabola. And then over here, another half parabola. So then that would be the secant graph. Again, the cosine curve, I put in dotted because that's the reference graph. And then the solid one, the secant, and that'd be the secant graph. Now, for those who might be wondering, how do I do the one cycle test for this? So for the one cycle test is pretty similar from 0 to 2 pi, but don't forget about the interval right between. You'll see that. So we'll find the vertical asymptotes right between those midpoints, okay? So got to be careful with this. It's not from 0 to 2 pi, but also we need to find out the vertical asymptote positions. So it's always the interval, the midpoint, right between the interval. So just put the notes on this. And now, what about for the sine curve? The cosecant graph. Again, we're using this one as a reference graph. So it's going to be dotted. Okay. And then again, at 0, so that's zeros. So the reciprocals of 0, then that would be considered VA, the vertical asymptote. And here's another VA. The value of pi. And then 2 pi. Once again, we use the exact same process. So for the maximum, minimum position, we'll get the vertices for the parabola. So this one is facing upward, and the other one is facing downward. As you can see that the parabola, so it's being bounded right between those asymptotes. Okay, So it's bounded right between those vertical asymptotes. And now, what about the one cycle test for the cosecant graph? Again, this one is cosecant, cosecant. So for the one cycle test of cosecant, so instead of going all the way from 0 to 2 pi, so this time 0 and 2 pi, they're not included. So there's no equal sign involved. And also don't forget about the other VA. So this time the VA, it's right in between the midpoint, well it's right at the midpoint of those two boundaries. The initial position and the final positions. So midpoint of the initial and the final positions. Okay? So we got a secant and the cosecant graph. Again, this one is just the fastest way or the easier way to recognize the parent graph of secant and cosecant. And also with the one cycle test. Now, what about tangent and cotangent? So tangent and cotangent, they're a little bit different. So for tangent, you might be wondering, a certain position, they're being considered undefined. Well, that's correct. And also, same thing happened with the cotangent. But how do we differentiate those two different type of functions there? Again, they're quite similar too, but the things that they're not exactly the same. So let's start with tangent. So y equals a tangent of bx. Again, this one is just the basic form. And then the transformational form would be considered a tangent b times the quantity of x minus h plus k. And for those students might be wondering, tangent, does that involve any amplitude? There's no amplitude at all. So the value of a, that's not the amplitude, okay? So this one is considered something else. It's called a scale factor. And not a scale factor. So it tells you whether that the graph is considered shrinking, stretching, and then the value b, another scale factor. And this one we use that to find out the period. So normally the way to find the period for tangent and cotangent is pi over b. And the reason why it's pi, because the parent graph, you'll see that in a minute. So for tangent, so we do have two vertical asymptote here. It's negative pi over 2 and pi over 2. Again, this one is just for one cycle. One cycles of the parent graph. And then tangent of 0, that's considered 0. Tangent of pi over 4, if you try to use a unit circle, then that would be 1. And then tangent of negative pi over 4, and that's negative 1. So once you connect those dots there, and it's a cubic curve. Now, see that right here? There's no any amplitude. Because this one, it goes all the way up to infinity. And the other side of the boundary, it goes all the way down to negative infinity. And for those who might be wondering, how do I do the one cycle test for tangent? Again, the one cycle test, it's all the way back to the parent graph. So as you can see, the boundary is from negative pi over 2 all the way to pi over 2. Again, whatever the element that you have after tangent without k, that's what you want to put in for the one cycle test. Again, whatever the value that you find out for the variable x, and that shows the initial vertical asymptote, and the final vertical asymptote. Okay? And now, what about for cotangent? So cotangent is quite similar. Again, it's under the similar structure. So y equals a, cotangent of bx. For the transformational form, it's y equals a, cotangent of b, times the quantity of x minus h plus k. So for cotangent of bx, so instead of starting with the VA and negative pi over 2, so we started at 0. Because cotangent of 0, that's considered undefined. And also cotangent of pi, it's also being undefined. Okay, so f pi here, that's being undefined. And then cotangent of pi over 2, that one just considered 0. Well, because that cosine of pi over 2, that's 0. Sine of pi over 2, it's 1. So 0 over 1 is 0. And then cotangent of pi over 4, and that's considered positive 1. Cotangent of 3 pi over 4, it's all the way down here, negative 1. So this one's kind of like a reflected cubic curve compared to the tangent curve. Okay, so reflected cubic curve, so it's going down this way, decreasing. Like this. Okay, let me fix this part. It's supposed to be a smooth curve. Okay. Again, the way to find out the one cycle test is all about the boundary of the parent graph. So this one goes all the way from 0 to pi, but 0 and pi, they're not included. Okay, so whatever that you have right between cotangent and k, and that's what we want to put in here for the one cycle test. Again, any number that you find out, so that's going to show you the initial VA and the final positions for the VA. Okay. Well, that's a lot of information. That's a lot of things that you need to know from pre-calc. So this one, it just shows you all the basic structures of all those type of functions you learned from Algebra 2, Trig, and then pre-calc. Now, what about any other additional formula? Formulas that you need to know. I'm sure a lot of you guys learned about sequences in series, okay? Conic sections, and also some of the geometric formula. Okay, so we'll talk about that in just a second. So for sequences in series, so normally we do have two different types of sequences. One is considered arithmetic, and the other one is called geometric. So arithmetic is just like 1, 2, 3, 4. So let's say that you want to count a number from 1 to 100. So you can see that from one number to the next number, you want to add 1. Okay? So anytime they see like addition and subtraction, that means always consider arithmetic sequence. So the formula that you need to know. So let's say that you want to find out the number of the 100 terms. So the way to do it, it's a sub 1 plus the quantity of n minus 1 times the common difference. So a sub 1, that means it's the first number that you started with the sequence. And then n, that's just an indicator. Well, the number of the term that you want to find out. And then common difference, which is considered what? The variable d, the common difference. And then a sub n, that means the number in the nth term. Now what happens if I just want to combine all the numbers together for this whole sequence, all the way up to 100? Well, the way to do it, it's called S sub n. So it's n over 2. So that means n for this one would be 100, because that's 100 terms. And then plus n minus 1. Well, it's actually plus. We're not doing addition for this. It's multiplication. It's a sub 1 times a sub n. Again, a sub 1, that means the first number that you started with. And then a sub n, that means the last number in the sequence, or the n term number. Okay? So once you put this all together, so you get that, the sum. Hey, Mr. Rahman? Yeah, I do have all the tests. I'm going to send it over later. Yeah, sure. Yeah, coming back. Yeah, bye. Okay, so now let's see what else that we have. For the geometric, so for the geometric one, so we do have, well, let's say we do have 1, and then 2, and then 4, 8, 16. So that means we just multiply from one number to the next number. So we multiply by 2. And the 2 right here is called a common ratio. So what we got here is a sub n, the way to find out the number of n term. Now it's a little bit different, so it's a sub 1 times the common ratio to the power of n minus 1. And then for the sum, so this one would be considered a sub 1 times r to the power of n minus 1 over r minus 1. Okay, so now those are the formula you need to know. Now what about anytime they see the infinite geometric series? So let's say that you have an infinite geometric series. So infinite geometric series, that means the number is getting smaller. So let's say we do have 1/2, 1/4, 1/8, and then so on and so forth. And then let's say that you want to combine this, all the number together, all the way down to the infinity term. So the way to find a sum, it's a sub 1 over 1 minus r. Alright? So that's a lot of information right here. And then for the other video I'm going to show you, it's all about geometry formula. So we'll just stop here for the first half of the essential concept of all the pre-cal content that you need to know. Okay? Thank you for watching the video today.